Okay, you guys are going to take notes on graphs and data tables on this sheet, and let's begin. You already talked about repeated trials. So data tables. We use data tables to organize our data. You've been practicing doing this in class. So you can see here we tend to, let's look at this example, number of germinations. You've got your different trials listed here. Obviously we do more than one trial. And we tend to list the independent variable here on the left. So you can see here they're doing different colors, red, orange, green, blue, violet, and sunlight, and then the dependent variables up here. So let's look at a practice here. As you can see on your note sheet, you have to answer the practice question. Here's a data table, and it says, does water pH affect tadpoles? It lists the pH of water and the number of tadpoles. So the first question is, what would be the IV? Well, the IV is going to be the thing that you can change, and it usually shows up first in the data table, but you can also use this title as a clue. It says, does water pH affect tadpoles? So they always list the IV first, and then after the word effect or affect usually comes the DV. So does water pH? That would be your independent variable, the pH of water. What would be the DV? Well, what's it affecting? The number of tadpoles. Okay, so when we look at a data table, you should be able to figure out what the IV and DV is, because usually IV comes first, DV comes second, or you can look at the title. Does water pH, IV first, affect the DV, so tadpoles? Obviously, we use graphs to represent data graphically or in a picture form, and we tend to actually put the averages in. We don't really always want to put raw data in a graph. So there's many different types of graph. Bar graph, obviously the one you're pretty familiar with. Bar graphs are used when you have qualitative data and quantitative. So remember, qualitative data is descriptive, like a soccer ball, a softball, basketball, whereas quantitative data is numbers, quantity numbers. So you use a bar graph. Circle graph or a pie chart, not used quite as frequently, and that's about proportions or percents. Scatter plot, which we will use a few times in science class, it is looking at two different quantitative data points. So there's going to be numbers. So for example, here you see the amount of time studied in minutes versus the quiz grade. And you can see a positive correlation. The more minutes you study, the higher your quiz grade is. Scatter plots are just a whole bunch of data points plotted on an XY axis graph, and then we put that line of best fit. So we'll practice those in class. And then a line graph is used to show a change over time, such as velocity time graphs, and we'll practice this in class as well. And then the last graph that we use in science class is a histogram, and it shows trends. So you can see this is like scores in intervals, like who got a 0 to 10%, 10 to 20, 30 to 40, so on and so forth, and then the number of students that had that. In a histogram, the bars touch and their ranges, so it's not saying 1, 2, 3, 4, it's showing a range, 10 to 20, 20 to 30, and so on. What you do have to know how to do is find the IV and the DV in graphs. So on most XY coordinate graphs, the x-axis should be the independent variable, the IV, and the y-axis should be the dependent variable, or the DV. So we always look here, x-axis to find the independent variable, y-axis to find the dependent variable. Some people remember this thinking about pancake dry mix. So dry, D-R-Y, D for dependent variable is on the y-axis, dry, and mix, you have the manipulative or independent variable, so M for manipulative or I for independent variable is on the x-axis, dry mix. That's just an acronym that some people use to remember. So let's practice this. Here's a graph, and I want to know what the IV is. Well, I don't even have to really pay much attention to what the graph's about. I just remember that the IV is always on the x-axis. So what is the IV? Temperature. What's the DV? I look over here at the y-axis, solubility. Okay, so I don't have to know anything about what this graph is telling me. I just have to know that I always put the x-axis to be the independent variable. That's what I'm changing. So I'm increasing the temperature, and then the dependent variable goes on the y-axis. It's what I'm measuring, so the grams that dissolve at different temperatures. And that's your notes.